The goal of the plugin is to make 3D Gaussian Splats feel like any other asset would. Our holy grail has been always to make the artist feel they're using just another asset.
Relighting Gaussian Splats is now possible. And today we are going deep on what it actually takes to bring this technology into real film and virtual production workflow. I'm here with Fernando, CEO and co-founder of Volinga AI. Fernando initiated the early research that later became Volinga, a company building professional tools for creating, editing, and rendering 3D Gaussian splats for film and virtual production. And now Volinga covered the full pipeline, from reconstruction and editing to what I believe is the most powerful relighting solution for 3DGS in Unreal Engine. We start by breaking down exactly how relighting works on Gaussian splats and why it is not as simple as flipping a switch.
If you capture the splats and you have shadows on it, that's why we call it this additive lighting, because you are just adding on top of what you have.
We also get into what it takes to process Gaussian splats at a level that meets Hollywood standards.
With Volinga Suite, you have the full flexibility, but also the full complexity of building your own capture system, which also makes this very, very powerful for the media entertainment industry.
We look at the adoption challenges and how that looks like today.
If you tell me 1 year ago, you can see how there was still, let's say, fear of this new technology. A lot of these studios had never used 3D.
And that education pays off. We look at real production where this technology was deployed, starting with a use case that could not have been done in any other way.
The main problem they had is that they didn't want to allow film crews inside the camp. Using Volinga and Auschwitz together, the team was able to create this digital replica of Auschwitz-Birkenau camp. And now this is open to anyone to shoot and use this.
But before we get into it, I wanted to remind you that if you don't have the time to watch the full interview and want to learn from other founders and creatives at the intersection between XR and AI, you should definitely check out the XR AI Spotlight newsletter. By subscribing, you will get weekly interviews like this directly in your inbox and access to a list of tools and apps that allow you to experience Gaussian splatting in VR, on Quest, and Vision Pro. Just check the first link in the show description. And now it's time to roll the intro and welcome Fernando under the spotlight. Fernando, it is a real pleasure to have you here.
Thank you very much, Gabriel. It's really a pleasure to be here.
So, Fernando, can you introduce maybe briefly yourself and Volinga overall first?
Okay, so just say I'm Fernando Rivas. I'm CEO and co-founder of Volinga, and I have been in this exciting project for already 3 years now. And as you said, at Volinga we develop a plugin for Gaussian Splatting inside Unreal, but not only. Our goal is to make this technology accessible for all the professionals starting in the media entertainment industry. We have a virtual production specialization, but our mission is to go beyond that.
So, what can this plugin do right now and what cannot still be done with it?
So, the goal of the plugin actually in Unreal Engine is to make 3D Gaussian Splats feel like any other asset would. Let's say our holy grail has been always to make the artist feel they're using just another asset that is looking great, but they don't feel any difference between a traditional asset. Indeed, our plugin, yes, sir. So our plugin is through this always started with virtual production in mind. As you can see from the video, it was designed to work with ICVFX pipelines, Simulcam, etc. But it came out that as we were developing and adding new tools, adding new edition tools like cropping, being able to mask element, relighting, incorporating this with depth of field, reflections, interactions. So all of that started coming together, and while we were focusing on the virtual production community, a lot of other communities approach us and say, hey, what you're building is very interesting for us and we want to use it. So as you are seeing, the plugin can apply light, can apply depth of field, any process, camera control, or also color correction volumes, etc. But also it has certain interactions with materials with we can go over that in more in depth in the future, with reflections, with everything else, and allows you to edit and to play with the Gaussian Splats as you will with any other assets. I would say the main limitations right now of the plugin are two: for the Gaussian Splats and physics. There are workarounds, but that's let's say our homework for what's coming in the future.
You mentioned a few keywords here, right? And one is, for example, materials, right? So I imagine that, for example, one of the perks of having Gaussian splatting is this view dependence effect, this behaving great with reflective surfaces. How does the plugin manages and deals with this, let's say, more complex, in a way, surfaces?
Right. So there are two ways, and we like to see the plugin as an hybrid approach, where you can combine Gaussian Splats and traditional graphics. So Gaussian Splats are probably our audience know, but it's good to refresh, are really good at representing reflective surfaces or surfaces that change depending on the view direction, and that's because it, besides the base color, it has this spherical harmonics. This is not a thing that, let's say, a mapping that tells you, hey, if you are looking at me from this direction, this is the color, and if you are looking at me from this other direction, this is the color. So the spherical harmonics has different levels. This means the higher the level of your spherical harmonic, the more computation you will need, but the more complex reflections you can model. All plugin use until the third level, which is probably the highest that you have out there. And yeah, that lives very well with the plugin and Unreal. But this is important to have in mind that this is not actually a physical material. This is a trick, let's say, to represent these reflections. And for instance, it could happen of having a reflected surfaces and a splat reflecting something that is in front of the splat, and it looks very realistic. But in the moment you add a 3D element into the scene, it won't reflect on that surface, because this is not a metallic material. It's just, let's say, the splats are landing by hard the reflections, but they are not understanding it. So that's the part where we added something we call proxy mesh behavior, where we allow the user to introduce a proxy geometry. Let's say, make that geometry and that mesh share some properties with the splat. And one of them are the materials. So in that way, you are telling our plugin, hey, this section of the splat have these specific materials, and that's where, okay, we start giving the splats or giving our plugin this understanding of how the material behaves, instead of just representing what it was captured.
So is this, because when doing some research, I've seen that you describe this relighting approach in two ways, like additive lighting and mesh-based lighting. Is that part of this distinction? Can you maybe break those down for us? And when do they apply also to the concept of the reflectiveness and added this mesh-based with certain properties?
Sure. So the main difference between, so there are two different concepts we would call to additive lighting, or we say mesh-based lighting. So the additive lighting, we call this or we refer to that to the way we relight on the plugin. Why is that? Actually, when you capture a Gaussian Splats, you are already capturing the light of the scene, which in certain occasions, that's what you want, and it's great, and this looks really realistic, especially on, when you have like a skyfall, or, so there is a lot of situation where you will like this to happen. But there are lots where you just need to change the light conditions of the splat. The problem is that if you capture the splat and you have shadows on it and you have some lights behaving in it, you are not removing the light. That's why we're calling this additive lighting, because you are just adding on top of what you have. There are some companies like People where are doing a really good job of doing this lighting and removing everything and just getting the composition of albedo and the rest of the materials. Which there are some experimental workflows in which you can combine People with Gaussian Splats to remove the existing light, and then in that moment, let's say you do that with a plugin, that will be actually a lighting without additive lighting because you have removed. But when we say additive lighting, is, hey, we are just adding on top of what you're giving us, because we are assuming you are not giving us a clean albedo. It's something what you capture. And then the difference between mesh-based lighting and additive lighting is that, and the rest of the lighting is that in general on the plugin, we estimate the normals and that's all, because we cannot estimate at this moment the properties of the materials. However, as I explained before, if you use the proxy mesh part of a plugin, you can provide the normals, but also the properties of the materials. And that's what we will call mesh-based lighting. So we are not estimating the normals, let's say the user is giving them to us.
So I want to go back on one thing, just so that I understood correctly.
Sure.
Are you saying basically there are some teams right now that are doing daylighting or Gaussian splatting? So there is some research that allows to, let's say, remove harsh shadow potentially, or some of this? Is that correct?
That's the idea, yes. And with some work that is, let's say, it's a smart approach because it's not doing the daylighting on the Gaussian splatting, is doing the daylighting before the Gaussian splatting is generated. So on the dataset, on the images, the soft images. So what these teams are doing is using tool technologies like EnVol AI to remove the harsh shadows and all the light of the Gaussian splats. And then once you have that, you train the Gaussian splats knowing that, let's say, it's clean of other light contamination.
Interesting. I didn't thought that makes sense to process the images first before something much easier to process than the output as a splat. Makes a lot of sense. Amazing. But Volinga is not just a plugin, right? I mean, you guys have also released this Volinga Suite. What's included? What does it do? Can you guide us through it?
Sure. So as I said at the very beginning, the idea of Volinga is not only to provide a plugin, it's to provide a full end-to-end workflow that allows professionals to use Gaussian splats, especially on a real engine. So Volinga Suite is let's say, the missing part of the pipeline, and we have just released a new version that includes two things: support to LightField Studio and support to LightField Studio and an editor. So Volinga Suite, or what we're trying to do with Volinga Suite is encapsulate all these tools and also build our own tools to make the users, to make a really simple and easy to use, but also powerful and professional tool to create 3D Gaussian splats and to edit them. So very recently, we have become sponsors of LightField, and in this new release, what we have done is use LightField as our training engine for Gaussian splats. This means that essentially you have all the speed in LightField Studio, and you have all the benefits and all the community that is pushing LightField Studio, but you have also the good things that you had before with Volinga Suite, which essentially is all the compatibility with all the third-party tools like Colmap or Metashape, and also the ACES and HDR support. This means we are able to process 16 bits Gaussian splats, and we are able to process splats that are compliant with the Academy, or the Academy standard, the Hollywood Academy standard. So that's on the training side of things. But then
just to make sure if I understood correctly, are we saying that, so one of the let's say complaints that people have about LightField is like, okay, it's complicated to set up, it is not exactly straightforward, like I would say post-shot, where you can even go as easy as drag the video in, images and frames are potentially even extracted. Are you saying that now the Volinga Suite takes on that role and that user interface, still relying on the power of LightField and flexibility?
That's right. Essentially, we are adding, besides that, on top of LightField, we are adding a, let's say, more professional power and project management focused interface, and also the integration with structure from motion tools like Colmap, of course, that is native, but also reality capture and Metashape. So that's the idea and that's the goal, and that's something that open source has been on, let's say, on our DNA since the very beginning. We started with Gaussian splats with Nerf and Nerf Studio, having a project like LightField, which is doing a lot of the work and amazing work for the community. Pushing that direction, we are very happy to both contribute to LightField actively, but also, being that layer on top that deliver this UX and UI to the end user.
Amazing. I mean, then how does this So would you say then, how does this compare, for example, to a tool like PulseShot or maybe a reconstruction from LCC from XGrids? Have you done some tests? Like, how does that work? Also, does it happen locally? Does it happen on the cloud? Can you explain us a little bit?
So everything runs locally. Right now, we are the majority of our users value a lot, let's say, being able to process with full confidentiality data, etc. But we are aware of some other use cases arising where you just need to be as fast as possible, even though no matter where you are. But right now, we are focusing everything locally. Compared to SGrids, I would say that there are different pipelines. And SGrids, the SGrid solution, as you see, is a really good solution because it's really well engineered to work towards their sensor. So it's like an, let's say, an Apple, like Apple environment. Everything works towards the hardware, the sensors, etc. But there are some limitations when you work with SGrids because you are working with the sensors. For instance, you cannot have a high dynamic range or a bit. I think they have only 8 bits of color depth. With Volinga Suite, you have the full flexibility, but also the full complexity of building your own capture system, your own pipeline, and you can use any camera you would like. And as I said, we process HDR and ACES Gaussian Splats, which also makes this very, very powerful for the media entertainment industry. And that's essentially the main difference with for example, PulseShot. We're more built towards this professional high-end creation where you can have all the color information, the dynamic range, which is very important on VFX and virtual production workflows. And I would say the second, and then regarding reconstruction speed, we are on par. We are very similar. I would say that with this new release, we are a little bit faster than PulseShot, but it's true that it highly depends on the data set, on the training strategy you choose. As you may know, this includes a lot of variables. But also the other, I would say, thing that differentiates us from PulseShot is that we have put a lot of effort into our new editor, which is quite similar to SuperSplat if you look at it, but it's all built in-house, is our own editor. And the idea that we have with Volinga Suite in mind to create and develop this editor is to have one tool and one workflow, and at the end of the day, one vendor that can serve all the tool chain for Gaussian Splats. Because one of the things our users or clients tell us is like, hey, your plugin is great, but sometimes it breaks with this other tool, or sometimes I would like to have the support you have, or the support you give me on the professional side of things for all the tool chain. So that's kind of also the idea behind Volinga Suite. It's not only trying to improve and obviously trying to give the best tool to the users, but also give it in a environment that is full 360, all the tools you'll need for virtual production. Because of course, as we probably will discuss later, there are some synergies between when you use both the plugin and the suite together. But yeah, as I said, well, that's being said, it's true that we try to keep everything as open as possible. And then if you are using, of course, LCC Studio, we are compatible with them. We are partners of SGrids, and there is no reason why you won't use our editor, like I'm showing here, to edit some SGrids capture, or there is no reason why you won't use our plugin inside Unreal with an SGrid scan. Same thing with PulseShot. You can export from PulseShot and import into either Volinga Suite or Volinga plugin. We try to cover everything, but also we try to not hijack anyone and make them force them to use our solutions.
And maybe just quick to double check. At the end of the processing, do you get a PLY? Do you get some other kind of formats? What are we talking about?
So you can get a PLY, but also the de facto standard we use at Volinga Suite EnVol file, which is spelled EnVol. It's a proprietary format we developed actually a long time ago, and the idea was to keep all the metadata that the PLY files has not. This means it has some metadata and some information for optimization inside Unreal Engine, but also it has the color metadata, the range metadata. So in order to support this HDR ACES workflow end to end, metadata is very important. And that's, I would say, the key recipe for EnVol file. Of course, this can be exported into a PLY file. Metadata will be lost, but that's all proprietary format we're using.
So if I understand, this EnVol is what makes your PLY specifically suited for the Unreal high color accuracy applications.
That's right. So we are compatible with the OCIO, which is Open Color IO module of Unreal. This means that no matter where the data is coming from, we will convert that to the user requirements. But when you have the EnVol file with the metadata, you have a richer data that allows you to perform a better conversion and to make the results look stunning on the LED wall.
So just to summarize, right, this suite, you can do your processing, so you can build your own splats locally. Right. You can also do the editing. And within the suite, do you also get a plugin? And maybe like as also we transition, just in order of transparency, what's the cost of all this?
So the suite and the plugin are specified products. And then, as you said, with the suites, you can get the train, the processing of the splats. You can edit them. You can also get external splats and edit them on the suite. You can combine them and also build scenes that are also directly loaded into the plugin. This is very powerful because, for instance, you would probably like to isolate, I don't know, let's say specific elements like a tree or a chair, some elements in the scene, and load it in the plugin as individual elements. And then you run all together with the plugin. So that's also another benefit of using EnVol files. And the cost varies a lot depending on the kind of license you have, because there are licenses for just basic license, which starts at 15 euros monthly for the plugin, but also we have pro licenses for media and entertainment and studios, and we have deployment licenses, which is very recent. We are very recently for essentially package experiences like interactive experiences, VR, etc. So it depends on that.
And for the suite, for the reconstruction, what's the entry point there?
So the entry point for the suite is around 500 euros for a quarter, for 3 months. But also it depends, as I said, depending on the number of licenses, seats, etc.
Awesome. Amazing. It's good to know. I mean, the more, let's say, of these tools and opportunities that come out, I think the better, especially when they are all integrated. That's incredible. And maybe I might even have the chance to try LightField finally, because that's also one other thing, that is right. Like top of the line, but always struggling with the whole setup. So thanks for making that simple. I want to do a transition a bit, because we have discussed a lot about Volinga, sure. And we will keep doing that, but more in the, let's say, framing the use cases. So can you give us some example of what people have been, let's say, deploying and producing thanks to the Volinga's sets of services, I would say, at this point?
Yeah. So actually, there are different use cases that have been that all technology have been applied to. One of them being pre-visualization, which is actually one I personally like a lot. Let me just share a small sample. But the good thing, or what I like about pre-visualization, is that it's a use case that Epic itself was pushing a lot, which at the end of the day, the idea is to, let's say, shoot your film before you shoot your film and make all the creative decisions in advance, all the technical decisions in advance. However, the main bottleneck here is creating the 3D content because you're not shooting your film, you're doing this just in order to plan. So being able to do this at a fraction of a cost, because now you can just go there, capture, and 1 day, 2 days, you have everything ready to do your previs. It's been amazing, and I've seen so many teams using this, and I know it was something that Epic has pushed a lot, Epic Games, in the past, and now it's possible thanks to Gaussian Splats. Another use case that I like a lot is, let's call this digitalization of places. In this case, was for media entertainment, and there's a really nice project that we have the chance to participate last year that was led by the Auschwitz-Birkenau Foundation, which is a foundation, as you may imagine, that is responsible of preserving the memory of what happens on Auschwitz-Birkenau camp. And they have or the challenge that they have is that they have always wanted to do something in order to allow people to tell stories, because at the end of the day, the goal, or one of the most powerful ways of making people remember, is, telling stories about what happened there. But the main problem they had is that they were trying, or they didn't want to allow film crews inside the camp. Not even Spielberg was able to shoot there on the Schindler List, because it's also, cues are heavy, let's say, are loud, and it disrupt the memories and the place. So they always has wanted to do something like this, like a digital replica that people can use to shoot in and to create documentaries and stories, etc. But the problem is that they only close 2 days in the year, Christmas and New Year's, and in other 2 days it was impossible to capture this with photogrammetry. Using Volinga and S-grids together, here we team up. We were able to all the team was all the work was led by my friend Maciek here, which is a great professional. The team was able to create this digital replica of Auschwitz-Birkenau camp, and now this is open to anyone to shoot and use this, of course, after granting permission from the Auschwitz-Birkenau Foundation, but it's free. And I think this is a really cool project that enables storytelling at places that could not be done before. Yeah, I have, and the last use case that I would like to show is something that is streamed on Paramount Plus, and it's a CBS TV show called Find a Country, where it was a very interesting use case, because what they had to do is like a firefighter base. So they had some episode where they have to just go and rescue someone from a silo. And the problem is that shooting on the top of the silo was very costly and dangerous, both at the same time, because they have to build all the scaffold around the silo to shoot, and also the actors has to be there. So what the team at RCS Studio did, which they are a great studio, also providing this kind of professional services, they scanned all the environment of the silo. This was on a farm where everything was about to take place, and they prepared this digital replica on Unreal Engine using a plugin that could change, all the light, any materials, anything, as we saw before, depending on the requirements of the creative crew, and they were able to just build only the top of the silo on a BP state. So what they have is the physical top of the silo, but just 2 meters high. So everything was secure at 2 meters height, and everything else was LED wall. So you can see here in a second how this was external on set, but this is already on the BP set. This part is a physical silo built, but as I said, only 2 meters high, no scaffold, and no risk falling, and the background, everything else is the BP state. So this is another use case that was used on an episodic film on Paramount Plus, Fire Country. Yeah, that's also one of the, let's say, traditional use cases of virtual production that probably would have not been possible if it were not because the ability of creating this 3D content now with 3D Gaussian Splat is much cheaper and much faster.
So I have a question. When you approach these type of studios, when you have this conversation, have they already bought in Gaussian splatting or not? Because having a plugin to solve a problem of relighting implies in some way that they are already aware, they already have some sort of knowledge, they know how to scan, or maybe they are open to hire a company for scanning. How do you approach this conversation?
Yeah, that's a tough part, especially it was in the last year or so. You can see how a lot of the studios are now more aware of Gaussian splatting and now more aware of what are the benefits. They're still starting to adopt it, but you can see how the tendency of the industry is moving towards that line. But if you tell me 1 year ago, like let's say NAB 2025, you can see how there was still let's say fear of this new technology. A lot of these studios had never used 3D. They only have used 2D plates, so they also need to scanning, but they kind of know that with 3D, there is a technology promising everything is going to be cheaper now. So right now what we do is, let's say we have the part of application as part of education, right? When someone comes, we have people that comes and they don't know how to use Unreal because they have been using only 2D workflows, and now they know that this is much cheaper and much easier, and they need to use to learn how to use Unreal, or they don't know how to use scanning. Do I need to scan? Do I need someone else? Etc. So there's a bit of consultancy here and guiding everyone towards the right path. And for that, we have amazing partners like I say here, RCS Studios, which are based in Vancouver, which are a really good service company that are doing these kind of things. Also District Cinema, based on Tampa. There are these kind of companies that, let's say, are a step ahead, knows about that, and part of the business is helping these companies and also doing the scanning. And then, so we try to always redirect to these partners. And of course, we are aware of this company that they still require some education. And let's say your perfect customer on our side is those that, hey, I have already used 3D Gaussian Splatting. Now I understand what it is and what it isn't, because sometimes they have really high expectations. And then after that is, okay, now I want to use it. I have a project for this. Let's try it. And that's the moment where we jump into the conversation.
Of course, one of the main recurrent topic was virtual production being Volinga one of the main focus. But I was curious, have you been approached or have you done something that instead falls more into games, of course, Unreal, right? Or maybe virtual reality? What about it?
Yeah, so that's actually something we are working actively on. There are some projects for, I would say, something in the intersection between games and interactive experiences. And there are some projects for virtual reality. The main limitation of the plugin right now, to be honest, for this market is that it's still NVIDIA based. So you need NVIDIA hardware, NVIDIA GPU to run the plugin. That means that you cannot run on your headset, or if you are building a video game, you are limiting your targets a lot, your target market. So that's still I would say, the main problem that we're trying to solve to address those industries. But we have had projects like that. There are some things happening on that line, and definitely we want to address them because they are really cool industries. So let's say the whole thing about virtual production it was like the perfect market for starts because, all of them has a really good, powerful NVIDIA GPUs. It's run on Unreal, so it doesn't have to be shipped externally. So the plugin can, let's say, fail. Not of course, it cannot be crashing all the time because then you are wasting money, but it's more secure than when you just ship and deploy something. So it has been the perfect market to start, learn, and deploy. But at the end of the day, our idea is to make this available not only for virtual production, but also for video games, interactive, but also outside media and entertainment, architecture, product visualization. Those are markets I would like to explore definitely.
We have also, of course, assumed always throughout the conversation that anything that comes on a LED screen or is brought anyway within Unreal is, let's say, a replica, a scan of the real world, right? But we all know that there are different ways of generating splats from text, from images, or sometimes, as weird as it might sound, using Unreal as a virtual production studio to create these highly rendered photorealistic splats out of it. So there is a whole variety of ways, being indeed, as we mentioned, word labs, or maybe models like Sharp, or maybe other ways to create this synthetic splat, something that doesn't get scanned in the real world. What's your take on it? Do you think there is space for this in this industry?
Definitely. I think it's amazing. So I think that actually with SGrids, in the past, we could see that SGrids solve a big problem as a barrier of entry for a lot of people to use technology, which was, hey, capturing is difficult and I have to learn how to capture. With SGrids, it's easier now. But this is the next steps, right? Like, hey, you don't even have to capture now. I mean, of course, on all labs, you can still see that the quality is still generative AI. But I mean, if you see what happened with images and with videos, you can see where this is going. And you can see that probably next year, this is gonna be undistinguishable from reality. So that's even better, because now there is no limitation on where I want to shoot. If I have to go there, where? Because for instance, right now you cannot create a splat of Mars. Well, you could if you have a lot of money, but besides that, you cannot shoot there. In 1 year now, with the technologies like Apple Shop or Wall Labs, or what's coming next, you will be able to do that. And also, so that's, let's say, creating generating splat synthetically, but also the other path, the way of, having a 3D environment, a 3D scene. I create a splat out of it. It may sound redundant or, or senseless, but actually, if you think of splats not as a way of capture things, but as a way of render things really fast on any device, because all plugins is limited to NVIDIA GPU, but you have platforms that can run on any device, mobile, web, headset. So suddenly you're giving people a tool to visualize 3D anywhere without losing quality. I think that's amazing, and that's a really cool. I mean, it can be used for virtual production, definitely, because that's a challenge that happens for virtual production. But I think it also goes out beyond virtual production, and I think these like two ways where splats are going to grow, and the splats use is going to grow a lot, which is, as I said, using splats as a baking technology, as an intermediate technology, and now with the inclusion of splats in OpenUSD and the inclusion of splats of GLTF, I think this is only moving things forward. And then using splats as the base representation for generative AI. I think that's two of the things that make this technology really powerful and really, something to keep an eye for the next year or two.
The other thing is that you mentioned, and towards the beginning of the conversation, as being like one of the limitations so far for the plugin, is the animated Gaussian splatting. How do you see, let's say, what are the challenges that comes with using Gaussian splatting that are instead of static, but being like a performance, or anyway, something that comes to life?
So right now, I would say that the main challenge with 3D Gaussian splatting, with 4D Gaussian splatting, is that there is not a standardized way of creating them or representing them. So you can use a sequence of POIs, and the main problem of that is that it's very heavy. You have a lot of individual models, and it can become very heavy. And then there are some companies like Gracia, which creates their own file format, mint file format, and it's great, but let's say it still doesn't have a huge adoption the technology in the industry, even though I'm sure they are doing a great job, and it will become one of the standards. So at Volinga, we look at this in different ways, and what we are trying to do, and that's the work that is coming during this year, is being able to get sequence of PLYs and render that high speed, so enough performance in Unreal. And the challenge here is, okay, how do we get this sequence of PLY, shrink it into an asset that doesn't lose quality, but that is small enough for Unreal, because also Unreal is very picky with big files. And then we have to shrink it, give it to Unreal, and uncompress that on GPU in real time. So it's a technical challenge that we are working on it actively. But I would say once that's done, there is nothing preventing us for, doing everything we can do now, relighting, combining them, everything else.
So it is technically an issue of there is no really a standard for the Gaussian splatting. So what we're doing is solving for now the most obvious, even though cumbersome way of generating this, being having the flipbook and dealing with the whole compression and huge terabytes of file for a few seconds.
Exactly.
No, so I mean, If there are, maybe just I want to end with two questions. Like throughout your journey, right, you have dealt with a lot of companies that trying to, for example, build these splats on these LED walls and use them for broadcasting or maybe any other kind of applications. Are there maybe some tips or something that you can share with these teams who are trying to maybe sell these internally and showcase how they could actually work, something to simplify their life, really?
I would say the first thing these teams has to do since the very beginning, and there's something different, is changing the mindset of how 3D works. So usually people are used to very complex 3D environments that also works on this with a lot of materials. When they ask for a capture, and when they want to capture, they want like a very detailed capture of a full environment they can use anywhere. Sometimes with splats, it's best to, let's say, apply the divide and conquer strategy and focusing on specific sections, effective environments, because this is a very virtual production focus advice, but you never do a 360 camera pan on an LED wall. You just move it a little bit, some meters, depth of focus, etc. So sometimes it's easier to just split your environment, have different capsules that look great, and that's usually the easier way to start to get demos working, because usually you have to get different people on your team buying into splats, get demos, successful use cases, and you would then have time to know how to capture a full bidding.
More ambitious, scene,
Yeah.
Absolutely. So, Fernando, thank you very much. I just want to end. What can we expect from Volinga in 2026 then?
So yeah, as I said, 4DGS is something that is on our roadmap. The new release of Volinga Suite is something that, or the first step to something, to a new product strategy, which is building around workflows of Gaussian Splat. Gaussian Splat is becoming a commodity now. I think a lot of companies, a lot of technologies, a lot of software are starting to support it. We want to be that nexus in the middle that, at the end of the day, makes you easier to use the splats. That's what we're trying to reach. Adaptive LightField Studio was one step, but this kind of features are going to keep coming during this year.
Fernando, thank you very much for sharing all your learning. It was a pleasure talking to you.
Likewise, Carol. Thank you very much for having me.
Thank you very much for listening in. If you like the show, remember to leave a rating on Spotify, Apple Podcasts, or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlights on the greatest founders and makers, pushing the boundaries of XR and AI. Also, make sure to check out the show page xraispotlight.com, where you can find more conversation like this one. Till next time.